We have discussed about a block diagram, introduction, fundamentals, and block deduction rules. Now we will go for some examples with respect to the block diagram reduction technique. First, we will discuss once again what are the rules for the reduction of the complicated block diagrams. The block diagram of a practical feedback control system is often quite complicated. It may include several feedback or feed forward loops and multiple inputs. By means of systematic block diagram reduction, every multiple loop linear feedback system may be reduced to canonical form. It means that if the complicated block diagram is available, with the help of the transformation rules, we can reduce the block diagram. Then we'll discuss some general steps to reduce the block diagram. First step is a combine all cascade loops or the blocks using a transformation rule number 1. In the last YouTube discussion, we have discussed about all transformation rules. Around about 14 to 15 transformation rules are there, as we discussed in the last lecture. Step number 2, combine all parallel blocks using transformation rule number 2. Step number 3, eliminate all minor feedback loops using transformation rule number 4. Step number 4, shift summing points to the left and takeoff point to the right of the major loops using transformation rule number 7, 10 and 12. This is a very important step at the time of reduction of the block diagram. That is, always shift the summing point to the left side of the block diagram and shift takeoff point at the right side of the block diagram. Step number 5, repeat step number 1 to 4 until the canonical form has been achieved for a particular input. Step number 6, repeat steps 1 to 5 for each input as required. This step is for multiple input, multiple output, but we are going to discuss only for the one input and the one output. So for our reduction of block diagrams, we are going to use step number 1 to step number 5. Then we will discuss some examples. That is, example, reduce the block diagram of canonical form. Here it is, a block diagram is provided. It contains the some blocks names are there. Their transfer function is provided. G1, G4, H1, H2, G3 and the G2 is there. Then we'll follow the steps as like we discussed general steps for the reduction of the block diagram. First step is combine all cascade blocks using transformation number 1. We have discussed a rule for a block diagram that if two blocks will be in a series, we have to take a product of that. So here it is, a G1 and the G4 is in a series. There we are going to take a product of that block, block, whatever the G1 and the G4 is given. The second block is a combine all parallel blocks using transformation rule number 2. Here it is, two blocks are in a parallel. That is, G2 and G3 is in a parallel. We have to take a algebraic sum of that. That is, for both there is a plus sign, therefore G2 plus G3 is there. Next, step number 3, eliminate all minor feedback loops using transformation rule number 4. Here it is, as we have considered the G1 and the G4 in a series and we have to take a product of that, whatever that blocks is provided, then H1 is in a feedback path, so we are going to use the feedback transfer closed loop transfer function, that is G divided by 1 plus minus G of S into H of S. Here it is, our G is nothing but G1 into G4 and the H is nothing but our H1, and here it is, feedback sign is a plus, therefore in a equation we are going to use a minus sign, therefore G1 into G4 divided by 1 minus G1 into G4 into H1 is there. Then we will shift the summing point to the left and takeoff point to the right using the transformation rule number 7, 10 and 12. Therefore here it is, we will repeat the steps from 1 to 4 until the canonical form will achieve them. Once we will get a closed loop transfer function feedback for the feedback, that is a G1 G4 divided by 1 minus G1 G4 into H1. Then next two blocks whatever they were in a parallel, we have taken addition for that is a G2 plus a G3. Now these two blocks in a series, therefore we have to take a product of them. Therefore G1 G4 in bracket G2 plus G3 divided by 1 minus G1 into G4 into H1. Always remember, use the whatever the brackets are there required for every block. Here it is, don't forget to put the square bracket or curly bracket for a G2 plus G3. Then we will once again reduce the minor feedback loop with the help of same formula, closed loop transfer function, that is a g of s divided by 1 plus g of s into h of s. Here it is, whatever the upper block is there at the forward side, forward path, that is our g, and whatever in the feedback path, that is our h. Then next example we will discuss, example number 5. Simplify the block diagram. This block diagram is provided. Here it is. First important point is, by moving the summing point of the negative feedback by loop containing the H2 outside this positive feedback loop containing the H1, we will obtain. Here it is, what we have done, we have shifted whatever the summing point is there in between G1 and G2, we have shifted to the after the G1. Therefore here it is, at the feedback side at the H2, as we have shifted the summing point, H2 divided by G1 is there. As we have shifted the summing point after the G1, here it is H2 divided by G1 is there. Then the next, eliminate the positive feedback. Here it is, G1 and G2 is in a series, we'll do it in a series, therefore G1 into G2 is there, and then feedback it is a H1, therefore we are going to use the formula G1 divided G of s divided by 1 plus G of s into H of s. Here it is, the plus is there, so in the equation minus will be there. So here it is, we got G1 into G2 divided by 1 minus G1 into G2 into H1 is there. Then G1 G3 is in a series, so multiplication is there. Then after that we'll solve that whatever the upper feedback is there, that is H2 divided by H2 divided by G1. Same formula we are going to G of s divided by 1 plus G of s into H of s. The plus or minus is depending on what kind of feedback is there. If feedback is plus, in the equation minus is there. If the feedback is minus, in the equation plus is there. Therefore final answer, that is G1 into G2 into G3 divided by 1 minus G1 G2 H1 plus G2 G3 H2 plus G1 G2 G3 is there. Next we'll go for the next example, reduce the block diagram. Here it is, blocks are presented in terms of G1 G2 G3 G4 H1 H2 and the H3. First we'll eliminate the loops, that is G3 G4 and H1, and we'll move the H2 behind the G4. This is next step. For that we have shifted the takeoff point, as we have remember the formula, always shift takeoff point to the right hand side and summing point to the left hand side. Here it is, we have shifted the takeoff point. As we have shifted the takeoff point after the G4, H2 divided by G4 is there at the feedback side. Then we will eliminate the G3 G4 and H1. G3 G4 and H1, how we are going to eliminate? Here it is, G3 and the G4 is in a series, so therefore G3 into G4, and feedback is there, same formula, G of s divided by 1 plus G of s into H of s. Here it is, we have eliminated and we have taken the product of that G1 and the G4. Next we are going to eliminate the inner loops containing, here it is the multiplication with the G2, then feedback is there. Then we are going to do the multiplication with the G1 and the feedback is there for the H3. Therefore we are having the final answer is G1 G2 G3 G4 divided by 1 minus G3 G4 H1 plus G2 G3 H2 plus G1 G2 G3 G4 H3. Here it is very important formula always you have to use, that is the elimination of the feedback loop. Don't forget the formula g of s divided by 1 plus g of s into h of s, and that sign is depending on the what kind of feedback is there, plus or the minus is there. We'll go for a next example. Example number 7, reduce the block diagram. It's a very simple. First, two blocks are in a series, so we are going to take a multiplication for that. Then next block is in a parallel. It is in a feedback, not in a parallel. Parallel means, what do you mean by the how you are going to find out the two blocks in a series, or two blocks in a parallel or in a feedback? If if two blocks in a parallel, direction of both the blocks will be same, means their addition point or the entering point or the leaving point is the same. And if it is a feedback, forward path will be in a one direction and the feedback path is having the different direction, another direction, that two are will be in a feedback form. As here it is, we are going to eliminate first that first two, then one by one. Here it is, finally we will get this answer for that. It's a very simple example, easily we can find out the answer. Therefore the final answer is g3 of s, g2 of s, g1 of s divided by, here it is 1 plus g3 of s, g2 of s, h1 of s minus h2 of s plus h3 of s. We'll go for a next example. For the whatever the diagram is provided, find out or determine the following things for that. Open loop transfer function, feed forward transfer function, control ratio, feedback ratio, error ratio. Closed loop transfer function, characteristic equation, and closed loop poles are the zeros if k is equal to 10. We have discussed all the formulas in the last lecture. We can refer that whatever the formulas are there with respect to each and every ratio and the function, we can find out it easily. Next, reduce the given block diagram. The diagram is given, we will solve it for the each and everything. K 1 divided by s plus 1 is there. Then here it is 0.1 is there. First the both are in a series, therefore k divided by s plus 1 is there. Then there is a feedback. Then that is a feedback g of s divided by 1 plus g of s into h of s. That s function is there. So multiply our g is k divided by s plus 1 and our h is nothing but s. So here it is again, we are going to use the feedback g divided by, therefore after using, finally we will get g of s and h of s is like this, k divided by 1 plus k into s plus 1, and in a feedback 0.1 is there, that is h of s. Then as we are having the formulas for each and everything, first formula is open loop transfer function, b of s divided by e of s is equal to g of s into h of s. Then g of s is, h of s is already known to us, we can put here and we can find out the transfer function, open loop transfer function. Then here it is a feed forward transfer function, that is nothing but a g of s is already we have. Then control ratio is nothing but c or transfer function, c of s divided by r of s is equal to g of s divided by 1 plus g of s into h of s. As we are having the form for the g of s and h of s, by putting that particular g of s and h of s in that formula, we'll get all 8 whatever the unknowns we are having. Then I will discuss next example. For the system represented by the following block diagram, again same like example number 8. First we have to simplify this example, and with the help of whatever the formulas are there for each and every term, we have to fill it. Next we'll discuss about reduce the system to a single transfer function. Here it is, number of inputs are there, one input is there, one output is there, but number of that whatever the blocks are there, that are the more, that is somewhat complicated. But whatever the complicated terms are there or complicated examples are there, we have to follow the steps only one by one, so easily we will get an answer for that. First, move g2 of s to the left past the peak of points of the create a parallel subsystem, and reduce the feedback system consisting of g3 of s and h3 of s. Here we have done, we are moving the g2 of s to the left past, and as we have shifted, Therefore, here it is in the feedback upper side 1 divided by G2 of s is there. And we have solved the whatever the last part of the diagram, that is a feedback is there with respect to the G3 of s and H3 of s. We have used the transfer function formula feedback, that is G of s divided by 1 plus G of s into H of s, minus is there, therefore plus is there. Then next step, we'll reduce a parallel pair, whichever the parallel terms are there, that we will reduce. Parallel is there, it means in addition. Then we'll cancel out that whatever the summing junctions are there. We'll solve the feedbacks for that. First feedback is G of s into G1 of s into G2 of s, and H2 of s divided by G1 of s, and another one is H1 of s. First we'll consider, we'll combine these two, both are in a parallel, so parallelly we will add that. Parallel addition is there, and then that is a combine is nothing but in a feedback we are going to consider. And the last part, both are in a series, therefore multiplication of that is there. Then finally we will get this type of answer for that. Again multiplication, two cascade blocks. This is the final answer for that. G1 of s into G3 of s, in another bracket 1 plus G2 of s, divided by, in one bracket 1 plus G2 of s, H2 of s plus G1 of s into G2 of s, H1 of s, in another bracket 1 plus G3 of s, H3 of s. We will go for another example. Simplify the block diagram and then obtain the closed loop transfer function C of s upon R of s. This is from the book Ogata. This is page number 47. Procedure we are supposed to follow whatever the steps we have discussed. Here it is what we have done. We have first moved the branch point between the G3 and the G4 to the right hand side of the loop containing the G3, G4 and the H2, and then move the summing point between the G3, G1 and G2 to the left hand to the first summing point. That whatever the formula we have discussed, that is always shift summing point to the left hand side and the takeoff point to the right hand side. Therefore in this we have shifted takeoff point whichever in between G3 and G4 to the right hand side, and whichever the summing point is in between G1 and the G2 we have shifted to the left hand side. Therefore in a feedback loop there is a 2 points, we get 2 points we have added. 1 upon G1 is there and the H3 divided by G4 is there, as we have shifted the takeoff point and the summing point. Next we have to simplify it and we'll get this term for that. So these two blocks will be in a series and another one is in a feedback. Therefore we'll get a simplification result G1, G2, G3, G4 divided by, after simplification whatever we will get, that 1 plus G1, G2, H1 plus G3, G4, H2 minus G2, G3, H3 plus G1, G2, G3, G4, H1 and H2. This is the C of s upon R of s transfer function. Then we'll go for a last, or whatever the next example is, a reduce block diagram. It's a very simple block diagram. First step what we have done, here it is, we have shifted the summing point to the left hand side. Therefore in a feedback we'll get a R divided by G1 is here, H2 divided by G1 is there. The next what we will do, G1 and G2 is in a series. Therefore G1, G2 is in a series. Next here it is, we have to exchange whatever is here, it is the summing point, we are going to exchange in between H1 and the H2 upon G1. Here it is, we have exchanged that, and then after exchanging we have solved this feedback G1, G2 and the H1 with the help of formula G of s divided by 1 plus minus G of s into H of s. Here our G is nothing but a G1 into G2 and H is nothing but H1. This is the answer for that. Then next block, whatever the G3 block is there, that is in a series. Therefore multiplication is there G1, G2, G3 divided by 1 minus G1, G2 into H1 is there. Just like this. Then finally we will solve the whatever the feedback path is there, that is H2 for the G1. Same formula we are going to use, G of s divided by 1 plus G of s into H of s. Here it is, and then we'll finally simplify the whatever the feedback is, that is a unity feedback. And then finally we are getting g1 g2 g3 divided by 1 minus g1 g2 h1 plus g2 g3 h2 plus g1 g2 and g3. Then find the transfer function of the following. Here it is. First eliminate the loop number 1. Here it is a, whatever a is written, here it is, we'll solve this first loop. Then here it is a g2 divided by 1 plus g2 into h1 we will get. The next one is we'll move the whatever the point a behind the block. Here it is. So we got this, as we have shifted the takeoff point to the right hand side, whatever the g2 divided by 1 plus g2 divided by h1, in a reciprocal we have to add. Therefore in a series h1 we have added a reciprocal of that, means 1 upon j is there. Therefore in a feedback in a series with h1 what we got, 1 plus g2 h2 divided by g2 is there. Now h1 and this another block is there, that is in a series. We are going to take a multiplication of that and we are going to solve it. But remember, this is not a feedback, because as I told you, feedback is there, it means that both the directions are different. Here it is direction for the h1, whatever the line is there, and the h3 line is there, that is the same. It means that two are in a parallel. Therefore here it is what we are going to consider, h3 plus h1 is series with this block. Therefore h1 into whatever the block is there, 1 plus g1 g2 into h2 divided by g2 into plus h3 is there, because these two blocks are, these two lines are in a parallel. Then we'll eliminate that two loops whatever are there. Here it is. These two, here it is, we'll eliminate. This is the multiplication of the g1 with this whatever the next block is there. So we'll get this. And finally here it is a feedback. We are going to the same formula for the feedback. G of s is nothing but our whatever the first upper block is there in a forward path, and the h is nothing but whatever the block is there in a feedback path. Here it is a minus is there, so in the equation we have to use the plus, and it means that g of s divided by 1 plus g of s into h of s. So finally we'll get answer y of s upon r of s is equal to g1 g2 divided by 1 plus g2 h2 plus g1 g2 h3 plus g1 h1 plus g1 g2 h1 into h1. We have to simplify it with the help of, as I told you, what formula we are going to use. G of s divided by 1 plus g of s into h of s. This is the skill assessment or exercise. It's very simple. You can solve this transfer function. You have to find out c of s upon r of s. It's very simple. SS is in a series. You can go for that in a series. Then solve this feedback. That is s into s, then 1 upon s. But this is not a feedback. This is in a parallel. Why? Because the direction of both the lines, upper line as well as whatever the feedback line, that is the same. That's why both are in a parallel. We have to take addition of that. Then after that simplify the whatever the upper or unity feedback is there. Then after that you will get a 1 upon s is in a series with that you will get, and then solve the finally whatever the final feedback with respect to s, whatever the downward direction is there. So you'll get answer like this one. T of s is equal to s raised to 3 plus 1 divided by 2s raised to 4 plus s square plus 2s. Thank you very much.